All right, we are on page 17 in your toolkit, and we are looking at the area of circles, but now we're looking at just finding a portion of the area of a circle. So last week, if you don't have the parts filled in that you see on my page here, you'll need to go back to the week 13 toolkit. So we found the area of this entire circle. It has a radius of 14, and we kind of ignored the part about the sector. So now what we're looking at is we want to find the area of just this section right here. I'm going to highlight it a little bit. So we found the area of the whole circle. The area of the whole circle is 196 pi. That's our exact answer, and then this is our approximation. But if we want to find the area of just that part of the circle, I would take the entire area. Let's see, the area is 196 pi. And I would figure out, well, what percentage of the circle is 270? So if I were to think of this entire circle, well, the entire circle rotation would be 360. So I'm going to multiply this by 270 out of the possible 360 degrees. Okay. If you wanted to, you could also simplify 270 over 360. That should simplify to 3/4 of the circle. You can do that potentially in a calculator. You could also do 270 divided by 360, and you could say, oh, look, it's 0.75. Well, if you're thinking of that in a percentage, that's 75% of the circle, okay? So I'm just gonna leave it as is here. So I have the entire area of the circle multiplied by whatever angle I have out of the entire 360. So now if I go to multiply everything that's in my numerator, that would be 196. I'm not going to multiply out pi. I'm going to leave my exact answer. So 196, let's multiply that with 270. And then that's going to equal pi is still in the numerator. And then the only thing in the denominator is 360. So then what you want to do is just get a calculator to simplify that. So then we're going to divide this by 360, and we're going to be left with 147 pi. And that would be yards squared. So let me just show you one other way to have done that. You could have also just taken 196. As I said, 196, I could just multiply it directly by that 0.75, right? 0.75. Oh, okay, I got 147 here. Or I could have taken 196 and I could have said, well, instead of 270 and 360, let's simplify that to 3/4. So I could do 3 divided by 4 here in a fraction as well. And I would still get that 147. So that's if you want to get the exact answer. Okay. So for the area of entire circle, we have our formula here. The sector area, let's write our formula down. Pi times the radius squared times the angle, the central angle, we'll call that. So this angle here was the 270, all divided by 360. So we'll call this the central angle, or the arc angle, central arc angle measure. Okay. All right, so that's how you find the area of a sector. We're going to be practicing that in your packet as well. And then let's go to page 18. Now we're looking at just a length of something. So not the area now, not the part inside, but now I'm just looking for this length right here. Okay, so I know the circumference of the entire circle is 20 pi. Okay, that's the exact answer. But now I want to just basically take that, and I just want 45 out of 360 from that. So what is 45 out of 360? Let's divide that. Well, that's about 12.5% of the circle. I could also try to simplify. Let's see, does 45 over 360 simplify? Oh, it's 1/8 of the circle. Okay, so if you think about it, well, if I were to do 90 here, okay, well, that would be 1/4 of the circle. So yeah, that's 1/2 of a fourth, so it's 1/8 of the circle. So basically, I'm just going to take this answer and divide it by 8 because I want 1/8 of the circumference of the circle. So let's write out our formula for this. It's similar to what we just did on the prior page. So that was the circumference of the entire circle. So now for our arc length formula, It is 2 pi r, so this same formula, but we're going to multiply it by that central angle that we have here, all over divided by 360, because that's what a circle is out of. Okay, so then our formula here for our arc length is going to be 2 pi r. So we already know it's 20 pi, so that's the entire circle. Now we're multiplying it by that 45 out of 360. And you could have put that in one fraction here. Just do 2 times pi times the radius times 45 all divided by 360, and that would work. So let's go ahead and multiply everything out. We have 20. We're going to multiply that with 45. That's going to be 900 pi over 360. And that's going to be 2.5 pi. Typically, I won't write a decimal with pi, so I would probably leave this as a fraction. So if I wanted this in simplest fraction form, 900 over 360, this is going to simplify to 5 halves, or which is 5 halves is also another way to say 2.5. So for this one, I'd probably leave it as 5 pi over 2 for the entire arc length. And this is in centimeters. 5 pi over 2 centimeters. Okay, that would be the arc length, and that is the exact arc length.